GPT, Generative Pre-trained Transformer, is a type of language model developed by OpenAI. There is not a best GPT model, as the effectiveness of a language model depends on the specific task it is being used for and the quality of the training data it was trained on. There are several versions of GPT that have been released, including GPT, GPT-2, and GPT-3. These models have different sizes and capabilities, and the appropriate model to use for a particular task will depend on the specific requirements of that task. Google also has its own language models, such as BERT, bidirectional encoder representations from transformers, which are trained on a large dataset and can be fine-tuned for specific tasks. Like GPT models, the effectiveness of a Google language model will depend on the task it is being used for and the quality of the training data. GPT is a type of language model that uses a transformer architecture, which allows it to process input sequences in parallel and handle long-range dependencies more effectively than previous models. GPT models are trained using a large dataset of human-generated text and can generate human-like text when given a prompt. They can be used for tasks such as language translation, text summarization, and language generation. GPT-2 and GPT-3 are larger versions of GPT that were trained on even larger datasets. These models have significantly more parameters and can generate text that is even more human-like than the original GPT model. Language models are just one type of machine learning model that can be used for natural language processing tasks. Other models, such as classifiers and sequence-to-sequence models, can also be used for tasks such as sentiment analysis and machine translation. The quality of the training data is a key factor in the effectiveness of a language model. The more diverse and representative the training data is, the better the model will be at generalizing to new data and generating realistic text. One of the key benefits of GPT and other transformer-based language models is their ability to handle long-range dependencies in language. This means that they are able to capture the relationships between words that are far apart in a sequence, which is important for understanding the meaning of a sentence or paragraph. GPT models can be fine-tuned for specific tasks by training them on a smaller dataset that is relevant to the task. This allows them to learn task-specific patterns and improve their performance on the target task. GPT-3, the latest version of GPT, is an extremely large language model with billions of parameters. It can be fine-tuned for a wide range of natural language processing tasks and has achieved state-of-the-art results on several benchmarks. In addition to GPT and BERT, there are many other language models that have been developed by research organizations and companies, including Elmo, Roberta, and XLNet. These models have different characteristics and may be more or less suitable for certain tasks depending on the specific requirements of the task. Language models are an active area of research, and new models and techniques are being developed all the time. As the capabilities of language models continue to improve, they will be able to handle more complex tasks and generate more realistic text. One of the challenges in training large language models is the amount of compute power and data required. Training a model like GPT-3 requires access to large amounts of hardware and data, which can be expensive. Another challenge in using language models is controlling the output. While language models are able to generate realistic text, they do not have an inherent understanding of the context or purpose of the text they are generating. This can sometimes lead to output that is inappropriate or unrelated to the prompt. To improve the performance of language models on specific tasks, researchers and developers may use techniques such as data augmentation, which involves generating additional training data by modifying existing data in various ways. This can help the model learn to handle variations in language and improve its generalization to new data. In addition to natural language processing tasks, language models can also be used for other tasks that involve sequential data, such as music generation and protein folding prediction. Some researchers are also exploring the use of language models for unsupervised learning, where the model is trained to discover and learn patterns in data without being explicitly told what to look for. This can potentially allow the model to learn more about the underlying structure of the data and perform tasks more effectively. One of the main limitations of language models is that they are only as good as the data they are trained on. If the training data is biased or incomplete, the model will reflect that bias and may produce output that is biased or inaccurate. Another limitation of language models is that they can be computationally intensive to use, especially for large models like GPT-3. This can make it challenging to use them for real-time applications or on devices with limited resources. Some researchers are working on developing methods for improving the efficiency of language models and making them more practical to use in a wider range of applications. This includes techniques such as pruning, which involves removing unnecessary parameters from the model to reduce its size, and quantization, which involves representing model parameters using fewer bits. Another area of active research in language modeling is the use of transfer learning, where a model that has been trained on a large dataset is fine-tuned on a smaller dataset for a specific task. This can allow the model to learn task-specific patterns more quickly and improve its performance on the target task. In addition to their use in natural language processing tasks, language models are also being applied to other areas such as computer vision and reinforcement learning. The ability of language models to process and generate sequential data makes them a powerful tool for a wide range of applications. One of the key goals of language model research is to develop models that can understand and generate human-like text. This involves not only being able to generate grammatically correct and coherent text, but also being able to capture the nuances and subtleties of human language, including idioms, slang, and sarcasm. Language models are typically trained using supervised learning, where the model is trained to predict the next word in a sequence given the previous words. However, some researchers are exploring the use of unsupervised learning methods for language modeling, where the model is trained to discover and learn patterns in data without being explicitly told what to look for. In addition to generating text, language models can also be used for other natural language processing tasks such as language translation, text summarization, and question answering. One of the challenges in natural language processing is dealing with the variability and ambiguity of human language. Language models can help address this challenge by learning to handle variations in language and generating more natural and realistic text. Language models have the potential to be used in a wide range of applications, including chatbots, virtual assistants, and content generation. As the capabilities of language models continue to improve, they will be able to handle more complex tasks and better understand and generate human-like text.